This is an example that covers 0 over 0 structures involving a square root. It involves using a conjugate that will eliminate the square root. Now you can factor and cancel as an alternative. However, the conjugates method is more flexible should you see other radicals, and if you take care to employ the logic carefully. As with any limit, the first thing we're going to do is plug in the x equals a. So we're just going to see what happens if we plug in x equals 9. On the numerator we get 3 minus 3, and the denominator we get 0. This is again 0 over 0. This 0 over 0 structure, again, there are a few techniques we could use, factor and cancel. In this case, we'll use conjugates to eliminate the square root. To use a conjugate, what you're going to do is keep the same structure, and you're going to introduce what I call a well-chosen version of the number 1. So if you multiply a fraction by the number 1, you are not changing anything. So we'll take the original and we'll multiply by a well-chosen version of the number 1. This green fraction simplifies to the number 1, so we have not changed anything. Why we have chosen this particular fraction will be clear in a moment, but I just want to point out how we know that we have a conjugate is these are the same square root. These are the same constant coefficients here, and we have opposite operations, 1 minus 1 plus in the middle. When we distribute the numerators, and we will not distribute the denominators, so here distribute, and here do not distribute. In the place, either the numerator or the denominator, you will always distribute based on what you're trying to eliminate. Here we are trying to eliminate that square root of x minus 3 that's causing us trouble, so we will distribute there. We will not distribute in the denominator because it will make more work for us, not less. In a moment, this will all become clear as to why we made these choices. So if we distribute in the numerator, we get square root of x squared plus 3 square root of x minus 3 square root of x minus 9. And in the denominator, again, we're not distributing. We're just going to leave the factors. In the numerator, what you'll see is the 3 square root of x's cancel, and the square root and the square cancels, and we are left with x minus 9 in the numerator, and the denominator remains the same as it did before. And here you can see the cancellation of the x minus 9s, and this is exactly why we chose the conjugate the way we chose it, is so that this cancellation would occur, and why we distributed in the numerator but not the denominator. If we had distributed it in the denominator, this cancellation would not occur. We'd have to factor, and we'd be creating for ourselves quite the mess. We write down what is left behind. After the cancellation, we try plugging in the x equals a again and see what happens. So we get 1 over the square root of 9 plus 3, which is 1 over 3 plus 3, which is 1 over 6. That's just a number, so we have equality. Formally, the way we would write our answer, this isn't always required, but just to be careful, we write down the original problem and our final answer. This next example is another one where we use the conjugates technique, but the inside of the square root looks quite a bit more intimidating. As with any limit, the very first thing we're going to do is plug in the a value and see what happens. So here we plug in the 0 value for h, and we see 4 plus 0 under the radical, minus 2 over 0. So we get square root of 4 minus 2 over 0, which is 0 over 0. We do have the correct structure, 0 over 0. And the radical is present, which tips us off that we should be using conjugates. So we need our well-chosen version of the number 1. We rewrite the original, and then we're going to keep the square root the same, the constant the same, and then we're going to use the opposite operation. So we see the minus 2 over here, so we will change this to a plus 2 here. That 4 plus h inside the square root oftentimes intimidates students or gets them heading in the wrong direction. So make sure you take care. That radical is a single object, so we're going to distribute the numerator. We're not going to distribute the denominator. So as we had in the last example, we end up with the square root squared. So make sure you keep that 4 plus h together inside the radical. Then we get 2 of those radicals. Then we subtract 2 of those radicals. And lastly, we get a minus 4. And downstairs, we get a copy of the factors not distributed. As before, the middle terms should cancel. The square and the square root cancel. And we have the limit as h goes to 0 of 4 plus h minus 4 divided by h times the square root of 4 plus h plus 2. Here we see the 4 minus 4 cancel. And now a lot of students want to start canceling everything right away because they see the end result coming on the horizon. You should take care to do the different kinds of cancellation in different steps. So we did the additive cancellation in that step, and we'll do the multiplicative cancellation in this next step. The reason you would want to do that, take your time, is you're less likely to make mistakes on harder problems. Okay, so we get the limit as h goes to 0 of 1 over square root of 4 plus h plus 2. We're going to plug in h equals 0 and see what happens. So we get 1 over the square root of 4 plus 0 plus 2, which is 1 over the square root of 4 plus 2 is 1 over 2 plus 2 is 1 over 4. That is a number, which means we're done. That is our answer. And that's it.